Hello everyone, welcome to Make to Explore channel. First of all, thank you to all our subscribers, viewers and supporters. In this video, let us see a new computer vision, machine learning and artificial intelligence based project. Real-time hand pose estimation and classification on NVIDIA Jetson Nano development board. Yes, you guessed it right. This project is an extension of our previous project, body pose estimation. In this project we will program Jetson Nano to estimate and classify the hand poses, then subsequently recognize the hand gestures. So, without any delays, let's get started. Hardware and software setup for this project will be same as of last project. You must check out that video. All prerequisite steps we have carried out in that. If you replicated the body pose estimation project on your desk, then just follow along, no need to do any further configurations. If you want to build this project from scratch, then check out our other tutorials, where we have explained how to set up Jetson Nano in headless mode. You also need Docker container on your Jetson Nano. We also have separate video tutorial for that. Links are given on project's GitHub page, also in description of this video.
So, before going forward, just make sure that you have completed following steps. First, you need to set up Jetson Nano to run headless. Then, download or pull the Docker container from NVIDIA's GPU cloud. Then, you have to run Docker container and access the Jupyter notebook into that. Once above all the setup get done, our next remaining task is program Jetson Nano to estimate hand poses and classify them. For that we will use Python programming with different OpenCV and machine learning libraries. Let's see that in next session. We will first go through theory, documentation, and procedure of implementation given on NVIDIA's repository for this hand pose project. And after that, we'll see project's actual implementation on Jetson hardware. Go to this GitHub page, which is documentation page for this project. Here, they have given all the getting started steps, installation procedures, and other instructions to implement this project. Let's see. As we have mentioned earlier, this project is an extension of TRT pose for hand pose detection. This project includes pre-trained models for hand pose estimation, capable of running in real time on Jetson Xavier NX. We will try this on Jetson Nano. In our last project, body pose estimation, we have completed all the steps required to install the dependencies. If you came to this project after completing body pose estimation project, then you just need to install this traitlets package only. In that project, we use DLI Nano container. But in this project, we are going to use L4TML container because it comes with most of the important Python and OpenCV packages. Hence, for those who want to build this project from scratch, let's do all the prerequisites installations again, step by step. Let's first go to Jupyter Lab. Here, open terminal. Then, let's list what packages came pre-installed with this L4T machine learning container. For that, execute pip3 list command. Here, you can see these all packages comes with this container. Now, let's go back to hand pose GitHub guide page. Here, in getting started information, at step 1, they have instructed us as make sure to follow all the instructions from TRT pose and install all its dependencies. Follow step 1 and step 2 from this link, which is body pose estimation project repositories link. Let's see. Go to this link. Okay, here you can see. We have to follow these two steps. Here, in step 1, they have asked us to install PyTorch and Torch Vision. But most of the requirements are already satisfied. Let me show you. Go to the Jupyter Lab terminal again. Here in this list, you can see these packages like Python, Matplotlib, NumPy, scikit-learn, SciPy, Torch Audio, Torch Vision, and Traitlets, etc. Likewise, These important Python and OpenCV packages are already listed here. Okay, let's go back to GitHub guide. So we need to install these PyCoco tools and TQDM packages. We also need to install one of the most important package, JetCam, which is necessary to use camera devices in Jetson. Let's go to its repository. Here, on this link, you can see they have given as JetCam is an easy-to-use Python camera interface for NVIDIA Jetson. It works with various USB and CSI cameras using Jetson's accelerated GStreamer plugins. Here are the setup commands to install JetCam. JetCam supports both USB and CSI cameras. Also, below here, they have shown some usage examples for cameras. And how can you read images using NumPy arrays, etc. Down here, they have given list of supported cameras, like Raspberry Pi camera version 2, IMX219, Logitech C270 and so on. Okay, now, let's go back to TRT pose guide. Here, let's do all these steps. Let's install PyCoco tools, TQDM packages, and JetCam interface. And then, this Torch2 TRT and TRT pose modules. Using these commands. Okay, we have completed all the steps from TRT pose, that was prerequisite. So, now we can clone the source code folder. For that, let's go to GitHub page of our current project, hand pose estimation. This one. Here, click on this code button. Here you will get the HTTPS link to clone this repository. Copy it. Like this. Then, go to terminal in Jupyter Lab. Go to L4T data directory. Here, type clone command and then paste the link which we have copied. Like this. And execute it. Project source code will get downloaded. You can verify it in File Explorer. Then, going back to steps guide again. Here in step 2. Install dependencies for hand pose. Like traitlets. But it is also pre-installed in this Docker container. Then, in step 3. You have to download model weight. Here they have given link to download this pre-trained model for hand pose estimation. Click on this download link. Download window will get pop-up showing that download got started. It will take some time to download that model. Its size will be around 85 MBs. We will fast forward this till download gets completed. Then, once download got completed, place this downloaded weight into the model directory. Let me show you. Go to Jupyter Lab Notebook again. Then, go to Files. Then, in Home folder. In L4T Data folder. Then, in TRT Pose Hand. Here is the model folder. Go into that folder. Then, go to top left, below menu bar. Here you can see this Upload Files icon. Click on this Upload Files button. It will ask you to browse the model weight file. Browse from where it got downloaded on your system. Select this ResNet model file, which have been got downloaded. As soon as you click on that, it will get start uploading into this model folder. You can see here, like this. Okay then, next, in step 4. You can run hand pose estimation and classification demo now. And also its applications given here. Like hand pose estimation demo, as shown here, estimating different hand poses. The next, hand gesture recognition, where we can recognize or classify different gestures. The next, cursor control application. And mini paint application, which lets you draw, erase and clear on your camera screen. We'll see their demo on our system, one by one. Go to Jupyter Lab. Here, before running demo of hand pose estimation, we need to check our camera first. Whether it is working or not. For that, we will use Hello USB Camera Notebook for our camera. Since we have connected Logitech C270 webcam through USB interface. If you are going to use CSI camera, then you can use Hello CSI Camera Notebook. We will share both notebook files on project's GitHub repository. You can also use notebooks available in JetCam folder. Let me show you. Go to JetCam. Then in Notebooks. Here they are. For both types of cameras, USB and CSI. Use according to yours. If you used Logitech C270 webcam like ours, then let's first upload this notebook file to Jupyter Lab. Click here on Upload button. Browse the notebook file from your computer and then upload here. Like this. Then open it. File is well commented. Here, read the description. In this notebook, you can test your camera to make sure it's working on the Jetson Nano as expected. It should already be plugged into the USB camera port. Make sure there is no obstruction on the camera lens, such as a film or cover. Then, execute the following system command to list all video devices on the Jetson Nano. To run the commands and cells in Jupyter Lab, you can use Run button given above here. Or, you can use keyboard shortcut. Shift-Enter. So, let's run this command. You can see our USB camera device is listed as Video 1. That's correct. We also used it in Docker run command. Then, down here. First, create a camera object by importing the USB camera class from the library by executing the following Python code cell. Please note, you can only create one USB camera instance. Set the capture device equals to the correct number found when you listed the system video devices. If you have dev video 0, then set capture device to 0. If you have dev video 1, set capture device to 1 in the code line below. So, we have to put 1 here. Like this. Then run this cell. Then follow and run the next cells, one by one. You will get widget with camera running. Here you can see live video stream from camera. In this way, you can test your camera. CSI camera testing will be same as of this notebook. You just need to follow the steps given. Okay. Finally, before you go or exit, shut down the camera and notebook kernel to release the camera resource, which is very important. Run this cell to do that. Like this. That's it. Now we checked our camera is working fine. Okay. Finally, let's run the hand pose demo. Go to File Explorer. Then, in Hand Pose folder. Here, first make sure that you uploaded pre-trained model weight file which we have mentioned earlier. In model directory. Here it is. Earlier in this video, we have seen demo of how to upload this file. Then next, open and follow Live Hand Pose Notebook. Here is the Live Hand Pose Notebook. Let's run it. You should run each of these cell one by one, sequentially. After you run the final cell, you can see here, real-time hand pose estimation is working on NVIDIA Jetson Nano. Pre-trained models for hand pose estimation capable of running in real time on Jetson Nano also. Although they are trained for Xavier board. So, in this way, we have completed this project. In upcoming videos, we will see some more applications of hand pose estimation. Like, hand pose classification, gesture detection, cursor control, mini paint application, gesture-controlled automation, etc. Stay tuned for more updates. If you face any difficulty in replicating this DIY project, feel free to ping us on Telegram, or you can also send us email at info@make2explore.com. We would be happy to help. Thank you.